Limit of the sequence. I have already explained here the topic limit sequence, and now we start the limit of sequence is that here the word limit, which means approximate value, or where we approach, either it is large or negligible, but in this sense there is negligible value which is smallest particle which close to the that number which is left or right. So here let an I already told you that an must be represent, an must be called the nth term or general term. So the definition of limit of sequence is that let an be a sequence, let an be is a general term or nth term, be a sequence, let alpha belongs to the real number. There is a condition, there is an other number which is belongs to the real number if epsilon belongs to the positive real number. Epsilon is a negligible variable which is close to the that point. You can say that this epsilon represent the limit, and this limit represent the this epsilon belongs to the positive real numbers. Positive real numbers start from the 0. We leave the 0 number and it must be start from the greater than 0 numbers, and there exists n naught belongs to the natural numbers, and n naught it must be positive numbers, either 1, 2, 3 or so on, because this natural n represent the natural number, and n natural numbers start from always be 1, okay, such that in modulus, this is modulus or magnitude, or you can say the length absolute value, an minus alpha less than epsilon. When we subtract this alpha from the general term in modulus sense, then the results will be, the outcome will be coming to less than to the epsilon, and there is two conditions are applied. Either this modulus written in two form or two conditions. Number one sense is positive and number second one is negative, and for all natural n is, for all n greater than or equals to n naught. I have already told you that when we put here n belongs to the whole number, it must be written as a naught, or it start from the a naught. If n belongs to the natural number, then it must be start from a1, because n natural number start from 1 and whole number start from 0. That's why we can say that this a naught, this situation we start from a naught. And now here n belongs, n greater than or equals to n naught, n start from either n greater than or equals to n naught, and here n this whole belongs to the natural number, then an converges to alpha, an converges to the alpha. So we can, how can we say this general term right in limit sense? So here an approaches to the alpha. Now when we applying here the limit point, limit n tends to infinity, infinity is unlimited, so an is equals to alpha, an equals to the alpha, or you can say that limit an is equals to alpha. Either you applying limit, put here limit or not, because limit always be start from here n naught belongs to the natural number, n natural number must be contains an infinite number. So that's why we can applying here n belongs to the infinity, means n represent unlimited numbers, so that's why we applying unlimited, we applying infinity, limit applying here infinity. So there is two possibilities from this sense. An minus alpha, when we modulus solve here modulus function less than epsilon, there is two possibilities, positive and negative. So first of all, when we break this modulus function, so an minus alpha less than epsilon, which is positive, and second one is when we applying second condition, then an minus alpha greater than minus infinity, greater than minus infinity, because there is the possibility is changed. So an, where there is alpha is in the sense of negative, and we replace this alpha from this side, then it converted into the positive sense. So this minus alpha, when coming to this side, then it converted into the positive. So an less than alpha plus epsilon. And now here same condition is here. When an minus alpha greater than minus epsilon, then it must be an, this minus alpha goes through the other side, there, that's why it converted into the positive sense. So this minus alpha converted into the positive sign, and this negative alpha epsilon is remaining same. So here we changed this greater than sign, because an greater than this number, when we say that, let's suppose we say 3 is greater than 2, 3 greater than 2. If we read in alternating, then 2 less than 3, we can simply we say that 3 greater than 2, 2 less than 3. हम ये कहते हैं कि 3 2 से बड़े हैं, 3 2 से बड़ा है। तो अगर हम 2 की साइड लें, 3 हमारा 2 से बड़ा है, अगर हम ये कहें कि 2 क्या हमारा बड़ा होगा? नहीं, 2 हमारा क्या होगा? छोटा होगा 3 से। यहाँ पर हम पहले बड़े को मुशाबहत कर रहे हैं दूसरे के साथ, यहाँ पे हम छोटे को मुशाबहत दे रहे हैं बड़े के साथ। सो देयर इज सेम कंडीशन हेयर, an greater than alpha minus epsilon. If we say that alpha minus epsilon is less than an, because here this whole number general term greater than this number and this number less than this number. So that's why the condition, when we replace the sides, then this side, this sign will be changed greater to the converted into the less than sign. So here alpha minus epsilon less than an, alpha minus epsilon less than an, and an less than alpha plus epsilon, and here an is this same. Let's suppose I told you that, let's suppose alpha is equals to, let's suppose 3, alpha is equals to 3, and an is equals to 2, an is equals to 2, and epsilon is equals to, let's suppose 1. Then what will be the result is, if we put here an is equals to 2 less than alpha, what will be value of the alpha is 3 plus epsilon is equals to 1. So this condition satisfied 4, 2 less than 4. Okay, if we say that this condition, how can we say that this condition is satisfied? So here this is an less than alpha plus epsilon, and there is same condition. First one is this condition, and second one is an alpha minus epsilon less than an. If we put here alpha, value of alpha is 3 and epsilon is 1, then what will be the result is 2. Then what conditions are satisfied here? Or you can say that you put here another other number, or you can put here 2 same. Let's suppose 2 is same, and you can put here 3. Then what will be the result is? Let's suppose I have put here 3 plus 2, then result will be 5. And if we put here 3 minus 2, and this is 2, then it will be changed. It will be changed because this is not satisfied here. So that's why we can say that there is satisfied, because 3 minus 1, when we replace this value, then it converted into the 1 less than 2 and 2 less than 5. So here we can written in this sense 1 less than 2 and 2 less than 5. So this condition will be same. Here first we put here negative, alpha minus negative first here, and then this an will be same here, putting alpha minus epsilon less than and an less than alpha plus epsilon. So that's our whole definition of the limit of sequence, and that's why we can solve the different problems of the function through the limit of sequence. So I hope you are understanding the whole topic. Inshallah, we are discussing about the more topic of the limits. Allah.